In this tutorial, we're going to show you how to import vectors that were created in another CAD package, adjust the XY datum, and then use those vectors to create a very simple tooling to cut a two-sided part. In the end, we'll take a look at our 3D preview of those toolpaths and note any problems that may occur and show you how to fix those. So this is where we're going to end up, but let's start off by creating a new file. So let's go up to File and Close. Okay, so let's open up our existing file. So if we come up to open an existing file, and we're going to choose our conrod file. Now, this has actually been created in another software package, and we're going to import this into our software so that we can demonstrate how to use a two-sided job to visualize this finished part and then to also save off tooling for it. So we're going to open this up right away and have a look at what we're working with. So let's take a look at our job setup. So we want to make sure our job type is double-sided. Now in this case, we want our units to be in millimeters, and we want it to be 130 by 60. And our thickness for our pre-made material, which is aluminium, our pre-made aluminium block, is 12 millimeters. For our Z0 position, we could use the material surface or the machine bed. We can also zero off of the same side, but we're going to assume here that our pre-made aluminium block has been cut perfectly, so we're going to Z0 off the material surface. In regards to our XY datum position, you'll notice that it's in the bottom left-hand corner, but it's using an offset. Now this was set in another software package before this was imported in, and you'll notice that it is minus 16 in X and minus 26 in Y, which means it now comes to the middle of this circle just here where I'm pointing my mouse pointer. As for the flip directions, I will keep that on this option just here, and I do not need to worry about design scaling. So let's just go ahead and hit OK. Before I move any further, I just want to go over some of the job setup details that we just used, especially in regards to our XY datum. Now, that datum position might have been used because this job needed to start in a particular point, which might indicate as to why the XY datum was set with an offset. Also, in regards to our flip direction, if you remember over here we have our flip direction between sides, I'm actually going top to bottom here instead of left to right. This indicates top to bottom, and I'll show you this. If I pop it to the top here, there's a button here that you can toggle to see the top side of your design or the bottom side of your design. Just something important to take note of. Okay, so to get things going now, we're going to need to prepare our vectors for this file. They did come in the way they were expected to, but because this is a two-sided job and we want our vectors to be centered in our worksheet, we're going to need to make a few little adjustments. So to do that, we're just going to select all of our vectors. So I'm just going to click and drag this box around all my vectors. Similarly, you can also hit Control A on your keyboard to select all of your vectors. Now I could hit F9 on the keyboard to move all these to the center of our worksheet, but I could also use this tool over here, the Align Selected Objects tool. So I'm just going to click on that. I'm going to come up to our top here. We want to align it to our material, and we're going to click this option here to align it to the center. And there we are. That looks great. Okay, so right away you can see that there's a problem, which is that the XY datum is no longer in the middle of our small circle here. So we need to fix that. And there is a couple different methodologies you can use to do that. But one way we're going to look at is actually by looking to correct it, by looking at the offset from down here to here and adjust that into our XY datum offset to get it to the right position. So to start doing that, let's go up to our Draw Polyline tool. And we're going to come right down to the bottom of the left-hand corner of the worksheet. We're going to click on that. And then we're going to make sure our smart snapping is toggled to on, which is indicated by the square around this button up here. And we can hover over this bottom left-hand corner of the innermost rectangle. Now, we're not interested in actually clicking on this at the moment. What we're interested in is the numbers up here. So next to dx and dy, we're interested in the values there because we're going to use those for our offset. So you can see that dx is 6.5 and dy is 4.0. This is diagonal x and diagonal y. So we need to jot those down somewhere, make a note of those so we can now go ahead and adjust our XY datum. So let's close out this form. And we're going to come back up to our job dimensions. and we're going to edit our offset now. So if you recall, our dx was minus 6.5, so we need to take that away. So because this is already a minus, we need to add another minus here. So minus 6.5, and then I'm going to hit equals on the keyboard. It gives us minus 22.5, and as you can see on the screen, the x datum has been moved, and we're going to do the same with the y. So the dy value was 4, so 26 minus 4 equals minus 30, and there we are. We now have our XY datum in the correct position, and let's just OK that. Okay, so with our datum now corrected, let's have a look at some of the details of a double-sided job. Now earlier, I did point out that if you come up to the top here and click on this button here, it will change the top and bottom side of your worksheet. Now next to it, it actually indicates what we chose in our job setup sheet, and this indicates we're flipping top to bottom. So that's what this symbol indicates over here. And this allows you to flip from top to bottom, but also indicates which side you're currently on. Now if you look at the arrow is pointing down to the top of the material. And if I flip it by clicking on this, you'll notice the arrow goes to the bottom, indicating that you're now on the bottom side of the material. You can actually also use 1 and 2 on the keyboard to flip between the sides. So you can just hit 1 and 2 on the keyboard and you can flip between. So 1 is top, 2 is bottom. And while we're on the bottom, let's go over some of the details on the bottom side to help you understand when you're actually on the bottom side. So for example, if you notice at the top here, our ruler color has changed. So if you go to the top side, our ruler color is gray, and we flip to the bottom, it's now turned to this kind of golden or amber looking color that we have on the screen. Also, you'll notice that your vectors are in light blue. Now this means it's actually showing you what's on the top side. So you can't actually select any of these. So if you see I'm clicking right now, I'm trying to select these, but I can't. That's because they're all on the top side. But this is useful for you to see what's on the top side, because if you need to line anything up with the top side, so let's say you were adding a circular vector here that needed to line up with the top side, you could do that because you've got these vectors to look at. So with that, let's just flip back over to the top side. Okay, so now we're going to copy all of the vectors that we have on the top side across to the back side so we can use it for tooling. So what we're going to do is we're going to select all of our vectors first. So click anywhere on the job sheet and we can drag this box around to select all of our vectors. And we're going to right click and we're going to choose the option to copy to the other side. Now, if I just click on that and then we flip down to the bottom side of our material, you'll notice you now have an exact copy of the vectors that were on the top side. And as you can tell, because of the change of the ruler color here, we are definitely on the bottom side, and we've got the arrow here indicating that we are on the bottom side as well. However, if you just want to double check, you can always do something like this where you grab one of the vectors. Let's just move this out of the way. And you'll notice now you've got this blue line vector, and that indicates that that's the top side version. So you know confidently that this vector with the black line is sitting on top of that blue line one, which is on the top side. So you know it's made the correct copy. But I'm just going to undo that now by hitting Control and Z on the keyboard to move that back. And let's just flip back to our top side. Now you may be wondering why I highlighted all of these and then did right click and then copy to the side. And that's because our software will automatically take into account our flip direction and place these vectors in the correct place in regards to our flip direction. This saves us having to do it manually. So for example, if you copy and paste all these vectors manually, so you copy them and then you paste them on the other side, this saves you having to line them up manually and potentially causing some mistakes, because the software will do all of that hard work for you and it will accurately map the vectors onto the other side for you. Okay, so now we have our vectors all set up. Let's start to develop some of our tooling. So let's step over to our toolpath tab. So to do that, we're going to come up to the top here and click this button here to move over to our toolpath menu. And as usual, the first thing that we're going to do is look at our setup for our material. But I want to tile the views to make this easy to look at. So if we come to the top here and click on Arrange Views Horizontally, and there we are, you can see our 2D view here, and you've got our 3D preview ready to go as well when we develop our toolpaths. So now with that set, let's go to our material setup and let's have a look at our material. So our thickness is 12 millimeters, our XY datum is in the bottom left hand corner, And as you can see, we're still using the offset that we set earlier for minus 22.5 and minus 30, the offset that we adjusted using our polyline tool, if you remember. We're going to Z0 off the top of our material surface. And we're going to make sure that our rapid Z gaps above material are clear and safe for our machine. But I'm just going to change these values to nice round numbers. So I'm going to change the Z gap above material to 10. I'm going to change the clearance values here for Z1 and Z2 to 5. And we're just going to hit OK. Okay, so for our first toolpath, we're actually going to look at creating a pocket toolpath. And to do that, I'm actually going to use this outside rectangular vector. I'm going to hold Shift on the keyboard and click on the outside circular vectors here because I want to remove quite a lot of material around this. And to do that, I'll do a pocket toolpath first. And the great thing about that is it will remove a lot of material, which will make subsequent toolpaths a lot easier to deal with, but also reduce some of the stress on our tool because it won't encounter as much material. So with our vectors selected, let's pop up to our pocket toolpath. And we want to set our cut depth to 2 millimeters, which will get rid of a good chunk of material for us. Now at the moment we've got this end mill populated here, which is actually in inches. We don't want that, so let's click remove and let's select the right tool for the job. So we want metric tool, so we want our 6 millimeter end mill. Right now these settings are actually pretty good, but I'm actually going to edit them just for this specific job, but I'm not going to do that here. These are the preloaded settings for your end mill, but I'm going to select this for the moment, and just to edit them for this job, I'm going to come over to this button here to edit them. And for this job in particular, I'm going to have a look at reducing some of these values because we are working with aluminium. So we want to slow down our tool a little bit as to not add undue pressure to it. So let's reduce this step over down to 20%. We're going to slow this right down for our spindle speed. We're going to go to 3000. We're going to make sure our feed units are in the correct units. So we're going to go for millimeters second. And we're going to change our feed rate to be 5 and our plunge rate to be 1. Again, slowing it right down because we're working with aluminium. So that looks good to me. I'm going to click OK. So that's my settings for this particular job. Next, we're going to make sure that we're using the offset strategy, which is what we want for the results we're looking for. And we are going to use some ramp plunge moves, and we're going to have it at a distance of 16 millimeters. And that's because we're going to use these across our project. So that way it'll take some of the load off that we're going to put onto our tool so that we can end up hopefully preventing any breakage of our tool. And with that, I'm quite happy with that. So I'm just going to call this our pocket, and we're just going to click calculate. Okay, so with that, we can now preview our toolpath. So with our pocket toolpath selected, let's click on preview visible toolpaths. And there we are, it's finished previewing our toolpath, and that looks pretty great to me. Now, as you can see, I've made sure that my material is set up in such a way that it looks closest to aluminium as I can get. Now, the way you can actually edit this is if you go up to the top right here and you click on this option here to edit material settings. And as you can see, the option that I've chosen for my appearance is steel. Now, let's say, for example, if you're doing this tutorial and your material is currently set to wood. So let's use Canadian maple, for example. This would then reflect this over here as well. But in this case, because we're using aluminium in real world, we want to make sure it's a metal and as close as we can get to it. So maybe use something like steel or even steel bright in this scenario. And there we are. I think that looks pretty great. Okay, so with that set and making sure that our material color is chosen as our option up here, we're going to now have a look at doing the same on the other side. So let's just reset our view for the moment. Okay, so to do that, we're going to need to flip over to the bottom side of this project. But before we do that, we should look at some of the intricacies around our toolpaths here. And I want to point out something that is on the right-hand side for our toolpaths here, which says top next to our toolpaths. So you know that this pocket is currently on the top side. So that's a good way for you to differentiate between the bottom and the top if you're not sure where you currently are, as well as some of the other methodologies such as looking at the ruler color and the arrow up here. But also, if it helps, you can also rename this toolpath. So you could always call it something like pocket top, for example, if that helps make it more clear for you. But with that said, let's close our preview down and let's pop over to our bottom side. So let's pop this button here to go to the bottom. Okay, so we're going to do the same thing here. We're going to choose our rectangular vector, hold shift on our keyboard, click the outside circular vectors with the left mouse click, come over to our pocket toolpath, and you can see that the software has actually managed to retain the information from our previous toolpath. So it's still got the cut depth, the right tool. We can have a look at the settings for this right now. And there we are, it's kept the 20%, the 3000 spindle speed, the feed rate and the plunge rate, so we can OK that. It has it set to offset, which is what we want. It kept our ramp plunge moves as well, so that looks great. So we can just hit calculate. And there we are, there's our bottom, as it says here, pocket toolpath. So we can run the preview for that as well. And there we go, that looks great. And now what we can actually do in the 3D view is flip over and see both sides at the same time. So there's the top and there's the bottom side of our preview. So you can see both sides have pocketed, and that looks pretty great to me. Okay, so let's just zoom back out and let's just pop our view back from top down again. So with that, let's flip back up to the top side. And now we're going to have a look at our second toolpath, which is to cut out this center section here to try and lighten up the weight of our connection rod. So with that said, let's make sure we select this vector and get it ready for toolpathing. So we want to make sure we're still on our top side, which we are, indicated by the arrow over here. Close down our preview. I'm going to come up to our pocket toolpath. Now, interestingly, you'll notice that we've already taken away 2 millimeters of material, and this is why it's important to have this horizontal tiled view, because you can always see your live preview. So if you notice, we've already pocketed away 2 millimeters worth of material, and this is where we're going to cut that central piece out from. So if we keep the current depth, it's just going to cut air because there's nothing currently there. So we need to start at a new depth of 2 millimeters, and then it will go down by a further 2 millimeters, which means it will overall from the top of the surface now be going down by 4 millimeters. We're going to make sure that our tools selected for this one is the 6mm end mill that we used for our previous pocket. We're going to make sure our settings are the same, so we come over to edit and we're going to make sure that we've got it to 20% for the step over, 3000 RPM for the spindle speed, 5 for your feed rate and 1 for your plunge rate. Now, if you're going to use these particular tool settings a lot, it may be worthwhile saving a variation of your tool with these settings. But for now, we're just going to click OK and have these settings just for this particular job. We're going to keep our ramp plunge moves to 60 millimeters. And with that, I'm pretty happy. So I'm just going to click Calculate, and then we can have a look at previewing our toolpath. And there we are. That looks great. So now we can do the same on the other side. So let's just close down our preview, come up to the top here, flip it over to the bottom side, again, select our vector, come up to our pocket toolpath, and the exact same settings. So we want to go to start at a start depth of 2 millimeters, to cut down by another 2 millimeters, to ensure our 6-inch end mill, or sorry, our 6mm end mill is selected with the correct settings for our step over, our spindle speed, our feed rate, and our plunge. And we're still using offset. The ramp is still 60 millimeters, so let's just click Calculate. And we can preview that as well. Okay, and that looks great. So again, you can look at both sides in your preview, and there we are, there's top and bottom for you. Currently, this is the bottom, and if I flip it over, we have the top side as well. Okay, so let's just pop that back down to the bottom side with a top-down view, and let's pop back up to the top for our next steps. Okay, so the next 2 toolpaths that we're going to make are only going to cut one of the 2 sides, and this is where you can choose, depending on your setup, where you would like to cut them. Personally, I would like to cut them from the back side, mainly because one of them was going to be a profile to cut out our material, and if we do that from the front side before we cut the second side, it might be a little bit unstable and it might break loose. So I feel that cutting it from the back side is probably a better option for us in the end. So let's flip over to the back side and let's have a look at creating our profile toolpath. But just before I do that, I actually want to address cutting out these circles here. So I will need to create another pocket toolpath just before I create my profile toolpath. So let's have a look at doing that while we're on the bottom side. So I need to cut out these circles. So if you recall earlier, we used the outside circles for our pocket. So this time we're going to use the inside circles here. Just going to select those. I'm going to close this preview and we're going to come up to our pocket toolpath again. But this time we're going to go all the way through all 12 millimeters of material. Now, if you've forgotten how thick your material is here or what you've set, you can always actually put Z and then equals on your keyboard and it will automatically fill that out for you depending on what you set up in your job sheet. Just something interesting to note if you ever forget what the value was and you didn't want to go all the way back to the job sheet. Okay, so with that said, I'm going to use the same 6mm end mill. Again, I'm going to edit the settings to make sure they're correct. So 20% step over, which is nice. 3000 speed, 5 on our feed rate, 1 on our plunge rate, because we are working with aluminium, so we don't want to put any pressure on our tool that we don't need to. So we want to be nice and safe. And again, we have our plunge moves, and let's just click calculate. Okay, so with our new pocket selected, we're going to preview that toolpath. Okay, and that looks pretty good. So the last toolpath I'm going to now do is the profile toolpath, which will run around the outside of our connection rod. Now, I'm actually going to leave some tabs on this when I cut it out because I'm not using any vacuum hold down or anything like that. So let's go ahead and make sure our vector is selected. We're going to close our preview and come up to the profile toolpath. And let's have a look at adjusting some of these values. So we know we're going to start at a start depth of 0, but we are going to make sure that we go for the full depth of our material, which is 12 millimeters. And we can have a look at now changing our tool. We want to use a 6mm end mill, so we'll go to select and we'll go to our metric tools and we're going to choose the end mill, which is 6 millimeters, hit select. And again, we're going to edit the values to not put so much pressure on our tool. So again, 20% in our step over, 3000 RPM for our spindle speed, 5 on our feed rate, and 1 on our plunge rate. And let's click OK. We want to go on the outside of the vector, so we're going to machine the outside of the vector that we've got selected here. We don't want to do a separate last pass, but we do want to add tabs to the toolpath. And I'm going to go for a length of 4 millimeters and a thickness of 4 millimeters as well. Now, if you recall, our pocket earlier took away 2 millimeters of material, which means in the end, your tabs will actually be 2 millimeters. So it's just something to keep in mind. So with that said, let's edit our tabs now and let's place them on our connection rod. So as you can see, now I've clicked edit tabs. I've now got this cursor with the tab symbol next to it. So I've got the cross for the cursor and the tab symbol just above it to the top right. Now, if I hover over the vector, you'll notice I get this check mark or a tick, and that means this is a place I can now place a tab. So with that said, I'm going to come over here, and this looks like a good place one, so I'll place one there, and just left click to place one, and I'll pop one just here, and again, in a similar location, just here on the other side. And I'm happy with that, so I'm just going to close that form out now. And I will add ramps to this one, which will be the zigzag ramps. And again, there'll be 16 millimeters. And I'm happy with that. So I'm going to now rename this to profile cutout. And then I can hit calculate. And now with that selected, I can now preview that visible toolpath. And there we go, you can now see what the tabs look like from the bottom side here. And if I flip that over to the top side, you can see that that's what it's going to look like from the top side with your tabs there as well. Okay, so let's just reset the view and let's look at it top down. And there we are, that looks pretty great. Now, the preview here is actually a really great tool in not just looking at what your final cut will look like, but also looking at some potential problems that may arise. And I can see one right away, which is that our profile cut is actually encountering the full depth of our material. So if you have a look here, we've got our pocket that comes up to the side here, to our side boundary that we've got for our rectangle. But then our profile pass goes into the full depth. So this is the depth that we've already cut away. So we've cut away 2 millimeters on this side here, for example. But this is the full 12 millimeter depth, and the tool has gone from encountering less material to now encountering more material on the side here. Now this could be a problem. So let's say we know that our tool can handle the depth that we've cut to for our pocket toolpath. So with our pocket toolpath material taken away, that we can now confidently use a profile toolpath to cut out any material inside that pocket toolpath, because we know that's a safe amount of material for it to cut. But as you can see, in this case, it's gone outside of that quote unquote safe boundary and it's cut into the full depth of our material. And this may lead to your tool breaking. So let's have a look at addressing that problem. So let's close down our toolpath preview. Let's maximize our 2D view. And now we can flip over to the top side, and we can either hit F on the keyboard, or you can use this button up here to zoom the active view to the drawing limit. It's this button in the middle here with a magnifying glass. So we use this boundary here on the outside, just like we use these circular boundaries for our pockets, and that lets us know where our machining boundary is going to end. This is where we're going to cut all of our part out in. But the problem is that we have this as our profile toolpath, and the distance between this and this outside rectangle is actually smaller than the diameter of the tool. So we need to address this. So we're going to actually make the distance bigger, or as big as the diameter of the tool, if not bigger than the diameter of the tool. But the first thing we need to do is delete our rectangle. So let's make sure our rectangle is selected, and we're just going to delete that by hitting delete on the keyboard. And we can flip to the other side and we can delete this one as well. And if we pop back over to the top, we can now look at creating a new boundary by looking at some of the snapping options that we have available to us. So there's currently a snap option that we don't have on, and we can look at that by going up to Edit and clicking on Snap Options. You can also use F4 on the keyboard to open up this menu as indicated by the F4 here next to Snap Options. But for now, I'm just going to left click that. Now, as you can see, it's got this form here with a ton of different options, which just shows how powerful this tool really is. But the one we're interested in is this one here. And we want to check this one so we can actually snap to the object bounds of our vectors. So with that selected, let's hit OK. So to show you how this works, let's go back over to our drawing tab. So we're going to go over to select create a rectangle or draw rectangle. And now what we're going to do is hover on the outside edge of our conrod over here. And what you'll see is that if I hover my mouse pointer over the outside edge, you see this blue line that I get now. And you see these two black dots in the corners, which are now the corner of the bounding box. So if I just hover my mouse pointer over to that, I can click on this and you'll see that I've got the corner which meets the intersection of each side of this outside vector. I can then click on it and drag up to the opposite corner now, and you can see the black dot has appeared for me to snap to. If I let that go, now that is the rectangle that is around just the edge of our vector. So it touches all the edges of our outside vector here, which is exactly what we want. So let's close that down. Now at this stage you may be thinking, well, this rectangle is actually a lot smaller than our previous one, so how's that going to work? Well, we're actually going to offset this one outwards. So we're going to make this one a lot bigger. So we're just using this as a bit of a template so we can make it larger. So with our rectangle selected, we're going to come over to this tool over here to offset this. We're going to offset it outwards, and we're going to go by 6.2 millimeters, which is just bigger than the diameter of our tool. And we're going to make sure that our create sharp offset corners is on. We don't need to select the new vector in this scenario, but let's click offset, and there we go. There's our new safe rectangle. So let's close this out and we can delete this one that we've created for the offset purposes. And now what we can do is copy this to the other side. So select it, right click, copy to the other side. You can check it's there. And there we are. This is the other side and there's that rectangle vector. So with that, we can now look at recalculating our pocket toolpath. So let's go back over to our toolpath menu. And this is on the top side. So we're going to make sure that rectangle selected, double click our first pocket, which is for the the outside circles and the rectangle. So again, make sure your circles are selected, hold shift, click on your outside rectangle, and we're just going to click calculate, and we're going to reset our preview. We can actually do this on the other side as well. So let's flip over to the other side and do the same for our pocket on the other side. Let's go back to our tiled horizontal view so we can see what we're doing a bit better. So again, I'm going to double click on our pocket. We're going to choose our rectangle, the outside circles as well. Click calculate. And there we go. So now we have our new toolpaths for our pockets. Now, with that all ready to go, we can now look at running all of our previews. So we can click this button here to preview all sides. So it'll preview the bottom and the top side for us. Okay, and there is our finished connection rod. And as you can see, this time it has gone right up to the edge of our boundary, but not into the full depth of our material, which is exactly what we wanted. So we wanted to avoid the profile toolpath going into this full depth of the material on the edge here, and that looks great. And with that, at this stage, you can now look at saving off your toolpaths. And to do that, I'll refer you to the two-sided machining introduction guide, which will be in the related videos below for you, so you can see how to do that yourself. But with that, let's close our preview. Let's maximize our 3D view here, and let's look at now saving our file. So let's come up to File and Save As. And I'm going to save this one as Conrod 2D Toolpaths. Let's just click on Save. Yes, I want to overwrite the one that already exists because this is the latest version. And there we are. There is our connection rod. And I hope you have thoroughly enjoyed this tutorial. That brings us to the end of this tutorial. And as usual, we look forward to seeing you in the next one. Thank you for your time.